Was the entire scientific community all wrong? The consensus among scientists is that there was something before the Big Bang, that the universe began with a Big Bang, is not necessarily true. Several researchers from different parts of the world have suggested that our current understanding of the Big Bang may need to be changed. The Big Bang may not have kicked off the universe's history, but rather a big bounce, according to new research published in the Astrophysical Journal. It's also possible that the Big Bang was only a convenient method to explain what happened at the end of the previous cosmic era, but way before the universe expanded. By introducing inflation, Cambridge astronomer Sonny Vagnozzi found a way around the fine-tuning problems of the hot Big Bang scenario. The finding also shows how quantum fluctuations generate the first structures in the universe, as the scientist puts it. Vagnozzi suggests that certain inflationary hypotheses could be true, despite receiving much condemnation. Because it has electromagnetic leftovers from when the universe was young, the cosmic microwave background is worth studying further. In early 2013, the Planck probe from the European Space Agency started taking measurements of the cosmic microwave, and the findings have astounded scientists all across the world. According to Harvard University astronomer Avi Loeb, the results from the Planck probe were held up as validation of cosmic inflation. However, many claimed that the data really demonstrated the opposite. Seeing the cosmos as it should have been immediately after the Big Bang is the only way to know for sure. After 13.8 billion years, the true restriction of the observable universe lies at the furthest that any signal could have gone alone, expressed by Loeb. This is because the speed of light is the ultimate limit to the distance a signal can travel. As the universe expands, this horizon has shifted by around 46.5 billion light-years. Exploring the sphere enclosed behind the barrier has been compared by one researcher to an archaeological excavation focusing on people, with the caveat that further exploration may reveal layers of cosmic history stretching back to the Big Bang. Nothing beyond the horizon can be known with any certainty. Nevertheless, studying the Big Bang, the universe's origin is crucial to comprehend the cosmos. If we could go back in time, we would only know some things about the past. Loeb says that the best way to understand the past is to have a theory of quantum gravity that can predict what will happen in the future. Although the system only makes incremental improvements, experts believe in it. Because of this, they say that the graviton background should be studied to find gravitons and other hypothetical fundamental particles. Several scientists have proposed the cosmic gamma-ray background's existence at the moment of the Big Bang. An explosion of such magnitude would disperse the CGB, making it almost impossible to find. The Big Bang hypothesis would take a severe hit if this were discovered. Even though advanced sensors will be required to find the CGB, the groundwork has already been laid. How do new estimates of dark matter and dark energy change our perspective? Recent measurements of cosmic obscuration have shown promise as the most precise to date. In 1998, scientists made a startling discovery about the cosmos. They found that not only the universe is really growing, but it also seems to be growing faster over time. Scientists later called this unknown force dark energy, which is now thought to be one of the biggest mysteries in physics that is yet to be solved. To characterize the unidentified material that acts as a halo around galaxies and keeps them from collapsing on themselves, astronomers coined the term dark matter in 1933. If this turns out to be true, it will go with the similarly mysterious dark matter, another mysterious energy that defies our finite understanding. Due to the use of mathematical models, we have been able to quantify the existence of dark matter and energy despite our imperfect senses and technological limitations. A group of astrophysicists has published a set of articles in the Astrophysical Journal this week that set the most exact constraints yet on the nature and history of our universe. Using the sophisticated analytic method known as Pantheon Plus, scientists have calculated that dark energy accounts for around 2/3 of the universe, while matter accounts for the remaining 1/3. Specifically, they believe that dark energy accounts for 66.2% of the cosmos, whereas dark invisible matter account for 33.8%. The mystery of how Pantheon Plus works might be more interesting than any dramatic changes it could bring. The team used a bank of solid cosmic lights to record the cosmos as it was more than 10 billion years ago. I'm referring to Type 1a supernovae as flashlights here. Brilliant stellar explosions from Earth, billions of light years away, may be seen. It's like a flashlight, except that it can see into the past and the future. Its existence was mostly proven when dark matter and dark energy were found in 1933 and 1998. The technological summit was Pantheon Plus. The more than 1,500 supernovae that were looked at in this study were thought to have lit up about 3/4 of the universe that could be seen. Scientist Dylan Brout from the Harvard-Smithsonian Center for Astrophysics said, "With this combined Pantheon Plus dataset, we have an accurate description of the cosmos from the time when dark matter ruled the world to the time when dark energy ruled the universe. When combined with other data, this dataset presents a once-in-a-lifetime chance to observe dark energy come on and alter the history of the universe on the largest scales up to the present day," as Brout put it. If this holds up, it might end some heated discussions in the scientific community. The Pantheon Plus's legacy will shine brighter than any star in that distant future. Analytical methods have also shown that the expansion of the cosmos is speeding up. The current philosophical cornerstone, the Standard Model of particle physics, has strong empirical backing. The existence of the dark universe is the subject of various well-known hypotheses, all of which can be traced back to this framework. It explains how every known particle acts on its own and in combination with other particles. In terms of limiting the dynamics in the history of the universe, we can create the most accurate limitations to date, as Brout put it. Moreover, we now have greater certainty than ever before in our ability to describe the universe's history, since the best hypothesis of dark energy and dark matter have not changed. That's why Pantheon Plus could insist we agree on certain non-standard model theories for dark matter and dark energy. The outcome of the Pantheon Plus datasets are also worth discussing. It has the potential to finally settle a hot argument among physicists. This may be the first step towards solving the mystery of the Hubble constant. Since the Hubble constant tells us how fast an object is moving at any distance, we can figure out that the age of the universe is equal to the time since the cosmos began to grow. But when did it begin expanding? Before or after the Big Bang? Understanding the whole science behind physics requires making testable assumptions. The testability of this statement gives scientists confidence in the rule of gravity. If you jump high enough on Earth, you will fall back to Earth. If a starship were to leave Earth's gravitational pull, it might continue moving until it collided with something massive enough to slow it down. The inflationary Big Bang theory is considered unfalsifiable by critics. But without the quick development phase, Vagnozzi and Loeb think they have a solution that is falsifiable and up to the requirements of the scientific process. Inflation theory proposes that shortly after the Big Bang, the universe experienced exponential growth. It was first suggested by cosmologists in 1981 when they were trying to find answers to a number of important questions. Their approach, however, requires radiation detectors built using technology that still needs to be created. They gave an alternative explanation that is just as hard to prove as the Big Bang Theory, which could show that the Big Bang Theory is wrong. It will be interesting to watch how scientists still devoted to the inflationary hypothesis respond to this new evidence. In the meantime, however, Vagnozzi and Loeb have come up with a solution to many of the universe's most puzzling mysteries that is more elegant and easier to understand than we have now. Do you prefer the idea of a massive rebound to that of a massive explosion? What do you think happened? Let us know in the comments below.